Welcome to Study Loop.
This is the answer to Chapter 21, problem number 70 from the Smith Organic Chemistry textbook. And this problem asks us to draw a stepwise mechanism for the reaction pictured in the problem. And really, it's just an enamine hydrolysis, and it's going to go like this. So in the first step, the double bond will grab a proton from the acid. So we're told that it's under acidic conditions. Simultaneously, the lone pair on the nitrogen is going to add in to the adjacent carbon. And so after that first step, we will be here. Oops. Can't forget your protons on your nitrogens. And so, of course, this nitrogen now has 4 bonds. So it's also going to have a positive charge. All right. And so the next step is going to be a molecule of water is going to attack this carbon, which is now susceptible to attack. So lone pair of the oxygen will come and attack there. These electrons will revert back to the nitrogen. And so now, after that step, we are at this intermediate. Okay, and of course the oxygen is going to have a plus charge on it. Oh no, and I forgot my nitrogen's hydrogen again. And so this next step is going to be another water is going to come along and grab one of these protons from the water that just added. And those electrons will revert to the oxygen. And so now we are here. And from here, what's going to happen is the nitrogen is now going to be protonated because, again, this is an acidic solution. So there are protons floating about. The nitrogen has a lone pair. It's going to grab one of these protons. It's now protonated. So the nitrogen is going to have a positive charge on it since it has 4 bonds. Next, one of the lone pairs of the oxygen will add in to the carbon that the oxygen is already bound to form a carbonyl. Simultaneously, this carbon-nitrogen bond is going to break. And so now we have formation of the carbonyl and release of the nitrogen as an amine. And of course, our oxygen will have a plus charge on it because it has 3 bonds. So we can use another passing water to come and grab one of those hydrogens, or pardon me, there's only one hydrogen. Come and grab the hydrogen. Those electrons will revert to the oxygen. I forgot. Oh, no, I didn't. No. Oof. About to say I forgot to draw a second ring, and of course we just opened the second ring. Okay, so from there, we now have formed our carbonyl. And so really this is the final product. The last step is just going to be, so we had an NH2, and of course, since this is an acidic environment, there are all these protons floating about. Nitrogen has a lone pair, so it'll grab one of these protons. And so rather than NH2, because it's acidic conditions, we have to call it NH3. So that's all that the last step is here, is protonation of that nitrogen. So NH3, and of course that's going to give it a plus charge, a positive charge. Okay, and so that's the stepwise mechanism for this enamine hydrolysis. And that's the answer to chapter 21, problem number 70.